Good morning, my Algebra 2A peeps. It is Lesson 8.4. This is Mr. Wilmoth. We are ready to roll here. Lesson 8.4 is going to deal with rational functions, which we know is 1 divided by x. The original graph kind of looks like that with those asymptotes there. And an asymptote is where the graph can't cross, what it can't be. So this would be right here. The y-axis would be a vertical asymptote. The red line, the red dotted line there, the x-axis would be a horizontal asymptote. So when we have these lines, 1 over x, we're going to do our transformations. Okay? So remember, it's pretty easy. Anything down here is horizontal. So minus h, that's going to be your bizarro down there, where minus is right, plus is left. Then outside is the plus k, there's your up and your down. And then the a there is going to be your vertical stretch or compression. Okay, so if we're looking here, we're just going to describe the transformation. Well, 1 over x plus 2. Well, that's down there in the bottom, so that's like it's in the parentheses. So that is left 2. Okay, over here, 1 over x minus 3. Well, that's outside. That's easy. That's down 3. All you're doing is saying what the transformation is. Okay? So, for a rational function of this form, the vertical line, or the vertical asymptote is going to be at h, and the horizontal asymptote is going to be at k. So your vertical asymptote is on what makes the bottom 0, and your horizontal is going to be that k value out there. So when you're looking at it in this form, identify the asymptotes. Okay, well, this is going to be, if you think about it, left 3 and down 2. So we have a vertical asymptote at the line x equals, remember we do the opposite down here, negative 3, and a horizontal asymptote at y equals negative 2. So if you were to see kind of a graph of that, that's where your asymptotes would be. Okay? A discontinuous function is a function that has gaps or breaks. So anything with an asymptote that we have is going to be discontinuous. It's got breaks in it if it has an asymptote. Continuous function means it has no breaks. Okay, so the graphs of some rational functions are not hyperbolas, but remember, anytime we have x on the bottom, that's going to be a rational function. All right, so if you look at this, we've got a vertical asymptote at negative 1. Okay? Just kind of, that's what this graph would look like if you were to graph this on Desmos. Make sure you put everything in parentheses, top, bottom. You might even need to go like that. Just make sure you kind of separate those out if you want to see them on Desmos. Okay, these are the notes of the table that I would have given you had you been here, but you're not. So you'll have to look in section 8.4 of your online textbook to kind of follow along with this. But these are all located there. Okay, so if you have irrational functions, zeros. The zeros of the function are what make the top 0. So whatever makes the top 0 is your 0. A vertical asymptote is whatever makes the bottom 0. Okay, so whatever makes your denominator 0. Okay, so your zeros are what makes the top 0. Your vertical asymptotes are what makes the bottom 0. All right, let's do it. Identify the zeros and the vertical asymptotes. All right, well, let's do the vertical asymptotes first. That's what makes the bottom 0. So x equals, what makes that 0? Negative 3. Okay? Our zeros, or our roots, those are going to be where it crosses the x-axis. Well, I'm going to have to do some factoring up there. What multiplies to 4 and adds to 3? That's going to be 4 and 1. And then I got to think here, that's going to be plus 4 minus 1. So your zeros are what makes the top 0. So your zeros would be negative 4 and positive 1. That's all we're doing. Vertical asymptotes, what makes the bottom 0. Horizontal asymptotes, let me start over. Vertical asymptotes, what makes the bottom 0. Zeros are what makes the top 0. We'll get into horizontal asymptotes here in a minute. Let's try another one. Zeros and vertical asymptotes. Well, vertical asymptotes again. Hey, it's the same. So that's x equals -3. And then 0, so we've got to factor the top. What multiplies to 6 but adds to 7? Well, that's 6 and 1, both positive. But when we write them as zeros, we've got to write them as -6 and -1. Okay? Zeros top 0, vertical asymptotes, what makes the bottom 0? So if you wanted to kind of, see a skeleton of the graph here, you could see that you'd have a horizontal or a vertical asymptote at -3. There'd be a 0 here and a 0 here. So then you could graph it on Desmos or whatever and kind of see exactly where those go, but you kind of have a skeleton outline of your graph. Okay? Horizontal asymptotes. All right, this is the one where you're going to need to check this out in your book as you're going through the assignment, the worksheet today. Okay, horizontal asymptotes. You got to know what the degree is. Remember, the degree is the exponent, okay? If the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. If the degree of the top is less than the degree of the bottom, then the horizontal asymptote is the line y equals 0, the x-axis. Okay? If the degrees are equal, okay? If the degrees are equal, then you got to do the leading coefficient of the top divided by the leading coefficient of the bottom, and that's your horizontal asymptote. Okay, that's a lot of information right there, but make sure you look it up in section 8.4. All these tables are right there in your online textbook, and you can see that stuff right there as you're going through the worksheet today, and when you're taking the quiz. Okay, so here we go. Identify the zeros and asymptotes of the function. All right, so we're going to have zeros, vertical asymptotes, and horizontal asymptotes. Let's just factor the top right now to get it over with. So what multiplies to 4 and adds to 3? That's going to be 4 and 1. I need -3, so it's going to be x minus 4 times x plus 1. Okay, so what are my zeros? Well, what makes the top 0? 4 and -1. Vertical asymptotes. What makes the bottom 0? Well, that's easy. 0. Horizontal asymptote. Okay, we have to look at the degree. Well, the degree of the top is 2. The degree of the bottom is 1. So top is greater than bottom. Okay, top is greater than bottom. If we have that, we go back to that chart, there is no horizontal asymptote. Okay? Easy peasy lemon squeezy. Let's try it again. Okay, same thing. First thing we do is we look, is there anything we can factor? Yes, we can factor the bottom. That becomes x plus 1, x minus 1. All right, zeros, here we go. Zeros. Zeros are what makes the top 0. What makes x minus 2 0? 2. Vertical asymptotes. What makes the bottom 0? Well, that's -1 and +1. Okay? And last but not least, horizontal. Degree of the bottom is 2. Degree of the top is 1. So your biggest exponent. So that means top is less than bottom, which means if you go back to your chart, y equals 0. Okay? Then you can go back. It says then graph. You could go to Desmos. If you're going to graph this in Desmos, I'd just go back to the original. Take that divided by that, and then you can kind of see a little bit of a sketch on Desmos as you're going from there. I can graph for us really quick on this graphing calculator right here. Let me do that real quick just so I can see what it looks like. So x minus 2 in parentheses divided by x squared minus 1. Boom, there we go. Draw. Ooh, that's a good one. Okay, so we've kind of got this skeletoned out here. We know we have a 0 at 2, a vertical asymptote at -1 and 1, and a horizontal asymptote at the y-axis. So this graph, then I can draw kind of in the lines here. Kind of looks something like that. Okay, and you can see that on Desmos. Just make sure you use your parentheses. Pretty slick, Rick. Okay, so zeros, asymptotes, vertical and horizontal. Zero is what makes the top 0. Vertical, what makes the bottom 0. Horizontal, you got to follow what the degree of the top and the degree of the bottom is. All right, let's do one more. So zeros, vertical, horizontal. What makes it? Nothing to really factor there. I suppose we can factor a 4 out of the top. Well, we can do that. It doesn't really change anything. So 4 if I pull that out, is going to be x minus 3. Okay? So what makes the top 0? 3. Vertical asymptote. What makes the bottom 0? 1. All right, go back to the original for this. Horizontal. The degree of this is 1. The degree of this is also 1. If you go back to your thing, the note sheet there about horizontal asymptotes, if the degrees are the same, you take the leading coefficient, which would be 4, over the leading coefficient, which down here would be 1. So 4 divided by 1 is 4. Okay, so that is all the different ways you can have horizontal asymptotes. You got to look at the degrees and go from there. All right, last thing, hole in the graph. If there's a hole in the graph, that's just where you can chunga, and that's where the hole would be. And they don't really show up on graphs. So, to find a hole, it's really easy. You do what we've been doing. You factor, so here we've got x plus 3 times x minus 3. I can chunga the x minus 3. So that means we have a hole in the graph at x equals 3. Anything that you can chunga out, that's where the hole is. All right? Okay, and then if you want to see the graph, these really wouldn't, the holes don't show up like on Desmos or anything, but it would just be a straight line there, but then you'd have a hole right here because you couldn't be 3. Okay, let's try that again. It says identify the holes in the graph. Well, you can know that you're probably going to chunga that. So x and x, 3 and 2. Yeah, it works. X plus 3 times x minus 2. I can chunga those two. So my hole in my graph is at x equals 2. All right, that is a long lesson today. There's the hole in the graph. And that is it for Mr. Wallman. Okay, I encourage you as you're going through the worksheet, I have the key to the worksheet for you. Make sure that you look in the online book in section 8.4. It's got all those notes that kind of tell you what's going on. Remember, 0 is what makes the top 0. Vertical asymptotes what makes the bottom 0. And your horizontal asymptotes, you got to do the degree of the top and compare it to the degree of the bottom. All right, worksheet's out there. Email me if you got any questions. Until next time, keep it real.